used that last year, but for some reason it kept popping out the little. We used polyester cord for it. Well, this time this he came up with. Credit there. All right, so we have one motor here and 3 gears that will just wind around this little kind of like spool, and as it pulls it in, it allows us to grab it. But we're thankful for it. It's relatively flexible, so there's little chance of actually puncturing or damaging Nessie's egg. And because of our camera placement here, we can see exactly how where we're going with that clause. And to fit the springs will pull it back, so its neutral position really is far back here, really open. And see, so far it's been able to grab, what was that one? It was about a pound of weight that it can hold. So underwater, it's if this egg is completely neutrally buoyant, then it's not going to weigh anything. So we're pretty sure that we'll be able to get it off up to the surface.
Yeah. And one more thing that's pretty unique about this claw. I actually made this gearbox at my house. I like taking apart like old electronics and stuff, and I took apart a VCR. And there was actually this worm gear setup inside the VCR that's used to, load the tapes and all that. So I actually used that, just a simple belt drive with a waterproof motor to actually create like a waterproof gearbox essentially. Just out of that. You can see that over there.
VCR parts. That's cool.
That's been it.
Are you going to have a way to turn the bait canister open?
No, we only had a capability of doing 5 motors. So, we chose what we chose and be able to have 1 motor and we can do the rotating.
What was your motor limitation based on?
Well, originally this tether and all this was for the Atom robot. And we forgot to mention, with the 2 robots that we originally had, the JV and Atom, one had onboard electronics and one had onshore electronics. We figured that way if we did have leaks, we still have 1 other robot, which actually worked to our advantage because now we do have 1, and they're not both leaked. So this tether was only had capability of doing 5 motors with all the wires. So unless we added to it, in which we haven't had time because all of us was last minute at the competition. The first time we said both robots in the water was yesterday morning.
Wow.
Yeah, we are kind of last minute on all this. Yeah. So, we might be able to, in the future, like next year's competition, obviously plan ahead a lot more. But yeah, that was our limit, mostly with this tether. So.
And torpedo, is that another thing we get to?
Yeah, we get to it.
It's coming next year though.
Do you do any math calculations, algebra, trigonometry calculus?
Well, we did a little bit for the motors. Well, last year we really did a lot of like heavy testing with these. Actually, like we created a force gauge and all that, like using like a lever and spring system to actually compare the different propellers and different motors and all the different configurations to see what would be optimal for us. And this year we kind of just based off of that, the same thing.
Also because we were limited to kind of unexperienced members that came in. Really, this is our first year, and really has been only a member for about 2 months now. So our senior members are either graduated or Mecca, Ecuador.
Yeah. Me and the vice president are the only 2 veteran members for this competition this year. So
we're just here learning and learning out what we can.
So we're definitely learning from our mistakes. As I said already, I'm quality control, and they felt my wrath when I go off on them for not making proper connections or not using zip ties correctly.
Or not having the electrical taped correctly to the wire.
Yes. So I don't let things slip by that.
Any questions?
So has this does not yet have your neutral buoyancy, correct?
Yeah, it's dry.
And you're going to put it in the water, and then what are you going to use to?
We have. You want to explain that?
We have 3-inch diameter ABS pipes, the ones usually used for drainage. Well, they're about 2 feet long. And we have end caps on one side that have been completely sealed by pressure gasket and what's that one? Log type
Silicone gel.
Yeah, silicone gel and epoxy that we pour down. So that'll completely seal off that end. And on the other side, we used a. Sorry, I know these these names in Spanish, but not English.
Coupling.
A coupling. And we use a female connector to have this little screw-on lid. Well, once in the water, we will just unscrew the lid, let water in. We can control that with twist-on cap. And then once we have a neutral buoyancy, we can just attach it. Actually, if you want to see video of, I decided to make a how-to video on how to.
Okay, now when you get to doing this, here's a cautionary note. You have a tube that has water in it. That water has the ability to rush to one side or another. If one side of the robot is heavier than the other and it goes down, then that water is going to flow to that end, and suddenly you're going to have a robot look like this. It's good to have some kind of, well, you probably don't have the time to do it now, some kind of baffling system to keep the areas separate, to keep the weight at one end or the other end. So that's going to be a little tricky for you. You might find that perhaps you can actually put something such as well, I don't know. I can't do your, and
Something solid, maybe.
something solid.
Yeah, we actually brought like big chunks of steel that we could probably just shove in there.
And that's also
Water doesn't work.
why we have ours big.
Oh, for steel?
Yeah, this is a how-to video.
Gas tanks solve this problem to some extent by having in them partitions with small holes that allow the gas to flow one way or the other. And that way, if you have a tipping, it limits the amount of time, or it lengthens out the amount of time it takes for it to flow that way. But that's done at sea on tanks, that tip a lot, if you can imagine it. But you might find it easier if you actually had, instead of one long tube, two shorter tubes. And you could put the water you want on one side, and therefore how much air you have on that side. And matter of fact, if you had two tubes, you could kind of adjust one forward or one backwards. But
Actually, that's what we actually have to do. Also, that we're working on.
Yeah.
They're trying though right now. That's why we can't bring them up here.
yeah, but aren't you using one on one side, one on the other side?
Pretty sure.
Yeah, there'll be one on each side.
If you had
Yeah.
a chance, t-shirt, you probably did, but the typewriter here, I don't know if you've seen that team.
Yeah, I've seen them.
Did you see their flotation canisters they built for RN? They actually found those at like kitchen supply place or something. So it's pretty interesting.
Yeah.
Definitely an interesting strategy for future years.
Yeah. Your robot looks good. I think you got a couple challenges yet before you actually get it operational in the water. But it does look good.